Okay, back again, talking about measures of position. We were talking about quartiles. And as I described, Q1 was the 25th percentile, Q2 was the 50th, and also the median, and Q3 was the 75th percentile. So to figure these out, the first thing we want to do is calculate the median. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it looks like these 2 points occur in the same point here. So our median is going to be 45. Now, to get Q1, what we do is we calculate the median of the points that were not that are on the left, I guess, of the median. So I'm going to go ahead and count this point. 1, 2, 3, 4. We're looking at 4 points here. So it appears this is the median on this side, 30. And using the same process, the 75th percentile, the median on the right side then, 1, 2, 3, 1, 2, 3, is going to be 60. So 25th percentile occurs at a value of 30, the 50th percentile occurs at a value of 45, and the 75th percentile occurs at a value of 60. So these are points that a lot of people use to represent data because it's easy to tell certain trends that are occurring in your data. And one way to represent this data is with a plot, with a graph. And we have a special plot called a box plot. That we can make. Now the procedure for making one of these, let's do it in maroon, is the first thing you want to do is you want to draw a line that represents the range of your data. Now you can start at or close to your lowest value, and since my lowest point in my data is 10, as you see up here, I'm going to actually start this at 0. And then I'm going to increment it by 10. 10, 20, 30, 40, 50. I don't think I'll do all the points. 60, 70, 80, 90, and then 100. And I can stop there because my data ends up stopping after 90. So 50, 60, 70, 80, 90, and I may as well put 40 in here. Okay, now the next thing you want to do is you want to come up here and you want to start setting up your plot. So the first thing you do is you set a point that is your lowest data point, and you can set a point that is your highest data point, and you want these to be kind of in a line with each other because you're going to end up drawing a line between them. So my lowest data point was 10, my highest data point was 90, so we got those two. So now we want to go to our first quartile at 25. Put a mark there. And our third quartile is 75 over here. Excuse me. My first quartile, my 25th percentile, first quartile, is at 30. So I'm going to draw a line there. We're going to make a box. And my 75th percentile is at 60. So I'm going to draw a line there at 60. So when you see a box plot, you know the edges. The left edge represents the first quartile, Q1. The right edge represents the third quartile. Now, then you draw a line between this point and your box, and you draw another line between this point and your box. And the last thing you do is you look at your median, 45, and you draw a line in your median. So that's supposed to be at 45. So this box plot then has a lot of information to it that we can look at. First off, we can see exactly in relation to the data where our quartiles are. Secondly, we can see where the median is. Sometimes the median falls to the left or right. This is pretty close to the center, and that usually represents a symmetric distribution, which we pretty much have in this case. And then you have, of course, your start point and your end point of your data, and you can look down here at the number line and see where everything falls. So it's kind of a useful thing to work with. Now, occasionally you'll see outliers represented. In fact, this is probably an outlier. This 90 is an outlier. An outlier is a data point that is very unusual and different from most of the other data points. It stands out as being very different. So 90 is an outlier. 10 is pretty close to being an outlier, but it's not really. And so that's sort of information you get off of a box plot. Now, the other thing you can do with a box plot is if you look at a typical box plot, sometimes you can tell the direction that your data set is skewed. And the way to do that is to look where the median falls. For example, if the median falls closer to the left side, you have a right skewed data set. If it falls closer to the left side, to the right side, you have a left skewed. And of course, if it falls in the middle, you have a data set that's probably symmetric. That's really all there is to. You might see these box plots sometime in your career or later on in life. That's pretty much all there is to it.